kitchen fan yang perlu diletakkan, dan juga living hall fan. Okay. Okay, kita tunggu sebentar ya. So saya harap adakah suara saya jelas? Saya respon sikit.
Jelas Doktor, jelas.
Okay. Terima kasih. So untuk topik ini kita akan lihat dulu secara teoretikal macam mana aircon tu berfungsi. Dan nanti kita selepasnya kita akan lihat macam mana nak kira secara mudah kuantiti cooling, kuantiti penyejukan untuk aircon yang diperlukan. Dia ada dua cara, iaitu cara cara sebenar detail tapi panjang, dan ada juga cara kedua iaitu rule of thumb. Saya sharekan slide dulu. Attendance yang kami pada akhir lecture kan. Section 2, 57 orang. Section 5, okey lah, 50 lebih. 9 lagi. Okey, sebelum kita start, suka saya nak ingatkan siapa yang dah ada dekat dalam kelas ni, kita masih lagi belum buat assignment. Saya belum bagi assignment. Saya akan bagi assignment dalam minggu ni, mungkin selepas kelas ni atau selepas hari ini. So assignment ni adalah berdasarkan chapter 2. So dia akan assignment ni, okay, detail tu saya tak ada dekat laptop satu lagi. Saya terpaksa guna laptop emergency. Okay, macam ni. Saya akan bagi assignment selepas mungkin besok. So apa beza assignment dengan projek? Projek ni dia long term, dia banyak chapter. Assignment ni just satu chapter. Sepatutnya saya bagi selepas chapter 2, tapi sebab ada beberapa pengubahan dalam soalan, saya bagi dia baru available sekarang. So dia punya untuk assignment duration dia dalam maksimum 2 minggu. So you kena bekerja dalam satu kumpulan 2 orang. Satu kumpulan 2 orang. Cuma saya tengah cari cara macam mana nak select 2 orang ni lagi mudah. Mungkin kita akan buat, saya fikir mungkin kita dekat buat group dulu dekat dalam projek tu. Lepas sudah kenal dia punya partner, baru you submit dekat assignment punya ruangan lah dekat author. Okay, so untuk assignment bekerja dalam 2 orang, hantar satu report yang mana ia adalah berkenaan dengan modifikasi dinding lah. You kena modify dinding. Nanti saya explain dalam video khas lah. Okay, then assignment akan diberikan. So mungkin deadline dia 2 minggu daripada hari diberi. Kemudian yang kedua quiz. Quiz minggu depan kita test kita test chapter 2. So alang-alang testnya 4 hari bulan malam. Sempat lagi lah nak bagi. Maksudnya 4 hari bulan Rabu. So minggu depan kita buat test chapter 2 lah. Quiz chapter 2. Quiz tu dalam 20 minit. Ada calculation, ada teori. Objektif dekat author. Itu saja nak update untuk quiz dan assignment. Dan kita akan ada quiz 2 selepas chapter elektrik. So basically kita ada lagi 4 minggu lagi. So saya akan cubalah untuk cover chapter yang baki. Jika tak cover, kalau tak kita akan gantikan dengan video lah. Cuma projek deadline dia mungkin saya akan extend sehingga study week. Okay. Termasuk you punya video lah. Cuma final class nanti mungkin yes. Boleh. Belum buat lagi. Belum buat lagi lah. Oh ya, itu untuk revision. Itu untuk revision, bukan. Itu revision ulang kaji untuk sebab kita tak buat kelas kan. So kita ganti online class, saya buat untuk revision sajalah, tak masuk markah lah. So saya ambil siapa yang jawab tu, tak kira markah, kira attend lah. Okay. Okay, baiklah. Thank you very much for attending this class. Good Assalamualaikum and good morning everyone. So today we will continue final chapter 3 about air conditioning system, sistem penyejukan. Okay. First kali mechanical, okay, saya nak terangkan sekali, nak highlight semula between mechanical ventilation and air conditioning. Okay, two terms. Normally kita panggil MVAC ataupun HVAC, heat ventilation air conditioning. Okay, so ada sebenarnya the term mechanical ventilation air conditioning adalah dua benda yang berbeza. So adakah aircon tu mechanical ventilation? So penerangan dia basically jika air conditioning tu ada circulation of air, if the air conditioning plus circulation of air, sorry tak cantik. Jika air conditioning system plus ada circulation, exhaust fan, supply fan, so dia boleh dikatakan mechanical ventilation. Ni konsep ni jangan salah faham sebab ramai orang salah faham. So termasuk saya masa mula-mula belajar dulu. So kita ingat aircon tu adalah mechanical ventilation, tapi tak semua aircon mechanical ventilation. So again, mechanical ventilation is ada exchange of air. Exchange of air, indoor, outdoor. Ataupun mechanical ventilation ni dia ada circulation, ada udara new air masuk, old air ataupun polluted air dapat dikeluarkan, circulation. So mechanical ventilation. So normally dia punya alat dia punya equipment adalah fan, totally fan, exhaust fan, supply fan, balance fan, liner. But air conditioning system ni dia just for cooling the air. Dia nak cooling or heating the air only. So air, udara yang ada dalam bangunan, dia nak udara yang melalui mesin tersebut, dia akan sama ada menyejukkan atau memanaskan. Tapi dia tak ada circulation, tak ada pertukaran dalam dan luar. Okay, so kena hati-hati kat situ. Okay, then air conditioning ini type, kita pergi pada type of air conditioning. So kita tak cover heating. Contoh sistem aircon unit dekat luar negara mungkin dia ada dua. Sama juga dengan kereta. Kereta import ada, dia punya aircon ada dua jenis. Kita boleh buat heating dan cooling. Tapi untuk kos ni sebab kita pun tinggal dalam negara yang panas, kita try cover yang cooling lah. Prinsip dia lebih kurang sama. So type of aircon, so dia ada split unit. Dan yang kedua adalah centralized unit. Okay, ataupun large lah. Centralized unit ataupun gunakan air handling unit atau guna chiller. Okay, split unit ni yang kita nampak dekat rumah lah. Yang kita gunakan dekat rumah, yang mana dia ni tak, split unit ni dia bukan mechanical ventilation tapi dia hanya air conditioning. So kalau kita ada rumah, contoh ada bilik, okay, aircon ni kita letak dekat indoor. Okay, itulah ni aircon. So split unit ini kat dalam indoor unit, dan mungkin dekat luar ni ada outdoor unit. Okay, yang indoor ni kita panggil evaporator. Okay, evaporator. Yang dekat luar ni outdoor kita panggil condenser. Nama dia condenser, evaporator. Okay, sebab apa yang split unit ni memang bukan mechanical tapi dia hanyalah air conditioning. Sebab dia contoh dalam ruangan ni, okay, so dekat depan ni biasanya ada air supply kan, dia supply udara sejuk. Okay, tapi then udara panas dia akan recycle lah. Dia akan sedut semula udara panas ni melalui atas, dekat atas, masuk dekat atas ni. So dekat atas ni sebab tu ada filter. Okay. So yang dia akan supply ke bawah, dia dah panas, dia sedut melalui atas lah. So dia circulate indoor air only by cooling. So dekat dalam split unit ni dia ada dia punya blower ada macam kipas lah. Kita panggil dia dalam ni ada blower. Blower ni saya andaikan dia kipas lah, macam kipas. Okay. Blower sebenarnya macam bulatan, dia ada sirip ni, dia ada sirip. Okay. Dia berpusing, dia keluarkan, dia akan meniup. So kita andaikan dia bentuk macam ni lah, simplify, dia macam kipas, kita nak tiupkan udara, dia akan meniup. Supply fan not ventilated, just to blow the air. Okay, dalam ni ada blower, nama pun blower, dia nak blow the air. Okay, so dia blow the air saja dia tak menunjukkan. So dia nak blow ke mana? Dia akan blow ke, kita panggil, dia akan attach cooling element. So cooling element dia adalah ada cooling coil. Dia kat dalam ni nanti depan dia ada cooling coil. Cooling coil dalam tu ada refrigerant. Cecair penyejuk. Okay. The fan will blow the air on the cooling coil where the cooling coil has very cold surface. Okay. So in the end, after leave the cooling coil surface, we can get cool air. So maksudnya dia just this system is just to blow the air to the cooling surface, then we can obtain cool air. It is similar like if you has ice and then you blow the air to the ice and then you get the cooling sensation. Okay. Now the question is how to make the coil cool. How to make this coil cool? It is depend on the refrigerant of the air conditioning. Okay, so refrigerant that normally people say get aircon gas. Sebenarnya dia adalah refrigerant. Refrigerant is, okay, kita pergi sini dulu. Refrigerant is a liquid gas material. The purpose is to absorb and release heat in air conditioning system, to absorb and release heat. Okay. Type of refrigerant, there are refrigerant fluid in split unit, small unit, and then water for big aircon, for the large building. You can use water or air lah. Okay, what is the characteristic of the refrigerant fluid or gas? The fluid that can change to gas when heated and return to liquid state when cold. So means refrigerant this very sensitive. During hot condition, when it absorb heat, it will become gas. So the sensitive, easy to change to liquid and gases state, vice versa. Yeah. This characteristic is easily to change to liquid and easily change to gas. Right. So it become liquid when it is become cold, and it become to change to gases when it become hot. Okay. And then there are many types. Okay. For example, now if you want to purchase aircon, it show that is it this R410A or R32 or R34A. So it depends on the type. So the price is different. Okay. So there are many types because they develop to make sure the refrigerant will not harm too much for global warming potential. So nowadays, the new refrigerant type already has zero potential for ozone depletion. Normally, this new one is okay for ozone, but still it is still a threaten ataupun apa, but still memberi sedikit memberi masalah kepada global warming. But for example, from this list, it shows that R32 is slightly better lah in terms of global warming potential. So basically, the gas, for me, the gas itself is not the to show the number is not to show which is better for cooling, but it is what is the effect on the global warming. So if you choose R32, slightly expensive means you less emission to global warming potential. Okay, that is about refrigerant fluid. Okay, so refrigerant. Okay, normally in split unit. Okay, basically, okay, let's go. Now you know about the type and how to make it cool, which is to make use of uh, refrigerant material. Okay, so let's look on the cooling cycle. Macam mana refrigerant ni menyejuk dan memanas. How the refrigerant become cold and become hot. Okay, basically it is you need to remember about heat transfer principle. Heat transfer principle. Okay, principle. Because all is about heat absorb and heat release. In this case, it's about heat absorb and heat release. Okay, so let's look into this typical air conditioning setup split unit. Okay, so normally there are main four components, which is evaporator, compressor, condenser, and expansor valve. Okay, again, evaporator is inside. Okay. Kalau kita lihat yang ni lah, saya ada video sikit nanti. So evaporator unit is inside of the room, and I outside name condenser. Okay, so here is evaporator inside, condenser is outside. So this normally you see, but inside the system there are also compressor. Okay, compressor in this unit you can see the black one. And then there is a expansion valve. Okay, this one. Okay, all this thing is to make sure the refrigerant can be regulate through the system. Okay, imagine this is all the equipment: evaporator, compressor, condenser, and expansion valve. So the movement is like this. Okay, imagine this is a cooling coil. Cooling coil, and inside the cooling coil is refrigerant. Okay, now we start from here. Okay, start from here. So okay, in indoor condition, during this condition the refrigerant is in liquid state, low pressure liquid, which is cool. Okay. So it will flow to evaporator. What happened here is, there is okay, of course the blower will blow the cooling coil, and then we obtain cool air. And the same time the hot air return to the coil. So what happened, hot air touch the coil. Okay, ini coil, for example this is coil. So when hot air touch the coil, so the coil will absorb. Okay, so the refrigerant inside the cool coil, refrigerant will absorb heat. Okay, so the hot air flow to the coil, and then the inside here, what happened is absorb heat. Okay, the liquid refrigerant will absorb heat. And then because it is sensitive to temperature, become hot, and then after flow and absorb, before it enter the compressor, it will become low pressure gas. It will enter the compressor as low pressure gas. Okay. Then inside the compressor, it will send the refrigerant to condenser. But before that, to make sure the target, the target is in condenser, we want to release heat. Okay. At condenser, we want to release heat. Sorry, color lain. Dekat condenser kita nak release, nak buang. Tapi dekat condenser ni biasanya dia ada coil plus fan. So the fan will blow to the coil and make sure the heat can be transferred to outside. Okay, to make sure the heat can be transferred, so the rule of heat transfer is heat always go from hot to cold, right? So this condenser is at outdoor. So to make sure the heat can be removed from the refrigerant is to make sure the refrigerant temperature should be higher than outdoor. Right. So when the temperature of refrigerant is higher than outdoor temperature, then the heat can be released to outdoor. Okay. So now before entering compressor, the refrigerant already absorbed the heat but low pressure. Okay, to make sure, then in compressor, to make sure the heat can be released later, so it will compress, making as high pressure gas. Okay, and then when already become high pressure gas, it will release to the outdoor by condenser, which is contained of coil and fan, and then it will return back and will go to expansion valve. Okay, so after leaving condenser, the state of the refrigerant is already become liquid, right? So because gas, when already release the heat, so it become liquid, but still high pressure with slightly hot temperature. Okay, to make it cool again, so the high pressure liquid, the expansion valve will make the flow slower. Okay, expansion valve will make the flow slower. Then when the liquid flow slower, it become from the liquid, it become like a cooling vapor or low pressure liquid. Okay, low pressure liquid. It will slow down the flow and make a low pressure liquid, which is cool. Then after it become cool liquid, it will flow again to evaporator and continuously, and the cycle continue. Right? Okay, that is how the cooling element works. How to remove heat from indoor to outdoor. So how the question is how the cycle continue. It is because of compressor. Compressor makes the flow continuously. But if the compressor broken, so the flow of refrigerant is not good, so it become a problem. So what we need to take care is a compressor. Okay. So until now, is it okay? Okay. All right. I try to explain one more time, and then I explain by video. Okay. Again.
Doctor.
Yes.
How about the centralized aircon? Is it same concept?
Slightly similar concept, but different equipment. Similar concept of cycle, but using different machine, different element. I will explain later. Okay, but the concept is to the heat exchange by using medium. The medium is refrigerant. Okay, again, maybe two time I will explain. So again, if you see this uh, figure, so evaporator inside, condenser outside. Okay, let's see. All right, compressor here, condenser, expansion valve. So the flow is like this. It always compressor to condenser, condenser to expansion valve, and expansion valve to evaporator. Okay. So here is cool liquid. Okay, and then go to the evaporator and then have blower, and we can get cool air, and also in the same time the coil absorb heat. And actually before it enter compressor, during this condition, before it leave enter the compressor, it should be 100% gases lah. So the system has been designed from liquid to gases. After it leave evaporator, it should be 100% gas, because compressor only can compress gas or vapor. So when it's enter compressor, it should be in 100% gas, hot gas, and compress, and then send to the condenser, and then based on the temperature different, delta T, so heat can be removed to outside. Okay, and then the refrigerant become a high pressure liquid and go inside to the expansion valve. Expansion valve means it has looks like a bottleneck. Okay, for example, it enter at the big entry and release exit with the small entry. So it becomes slower from big entry to small entry. It becomes slower and it makes the refrigerator become cooler. Okay. Okay. There is, if you want to see some simulation, you can check this YouTube. I will paste at the WhatsApp web. WhatsApp. Just in case to check. Okay. I will explain by myself. Okay. In this case, okay, we start from. Okay, this is about refrigerant. So refrigerant is easily boiled at negative 48 degrees Celsius. Means it easily to get hot, to change to gaseous state. Okay, okay. This is in evaporator. Okay, refrigerant in, and then at the same time we got the blows of air to the evaporator. Okay, so the heat is absorbed, is carried away by the uh, refrigerant. So originally from refrigerant is from liquid. After absorb, it become gas. Okay, and then next is go to compressor. Okay, I try to fast forward. Okay, go to compressor again. It should be 100% gas lah. So this inside compressor. So it will compress the air, become more hotter. This is before enter condition of particle or the gas before enter compressor, and then the compressor will compress. As you can see, the molecule become more compressed, it become more hotter. Okay. Okay, and then when it compress, the pressure will increase and the temperature will increase. Similarly, like your bicycle pump, if you pump and then you reach the high pressure, suddenly you feel the pump become hotter. This is because pressure, air pressure become high. Okay, and then at the condenser outside, similar like previously, so we want to remove the air to outside. Okay, so the hot refrigerant, and then absorb release the heat to the outdoor air by supply by the condenser fan. And then this is in the phase at the expansion valve. is like this. So expansion, before this, imagine this is expansion valve. This makes the flow slower, and it makes the liquid refrigerant become cooler when its flow slower. From yes, something like this lah. So it makes the molecule have more space and become cooler. Okay, so basically like that. So you can check this video later. Okay, so when you understand about this condition, basically, when we relate back how to reduce air conditioning energy or energy for cooling. So the most energy consumption used is for compressor actually. Okay? So compressor use more energy. So how to reduce, if you want to use aircon but to reduce energy, you have to make sure the compressor works effectively lah. So for example, how is the best way to locate your condenser? So your condenser is one. If, for example, if you have house, if your house is like this, okay, and then this is your condenser at outside. That's why people say that if you expose your condenser to direct sun, your location is not good. It is exposed to direct sunlight. So it become the temperature here, air temperature outside with the liquid, with the compressor, the condenser temperature, if the delta temperature is small, so the heat cannot release properly because temperature of refrigerant and outdoor maybe temperature difference is small. So less heat can be transferred. Okay, but if, for example, there is some shaded condition, or there are adjacent building that make your condenser shaded, so you can get a good temperature outside. So the heat exchange between condenser and outdoor is very good. Okay, so if in this case, because of the heat transfer is not good, so your compressor working because when this happen, the indoor become longer to cool, so compressor working much more. Okay, but in this condition, the compressor maybe can work smaller. Similarly, about your set point temperature, if you set too low, for example 18 degrees Celsius, so the compressor will stop after indoor reaching 18 degrees Celsius. So selagi until it not reach 18 degrees Celsius, it will work. That's why it is important to make sure you use set temperature adequately. For example, 24. So for example, early temperature is normally indoor is 20-30 lah. So if this maybe 6 degrees Celsius difference, and then maybe compressor will work how many? 30 minutes, 40 minutes to reach the set point. But if you sit too low, so it will work more lah. And then just in case, additionally, this another specification of air conditioning, there are some drain tube. Okay, so drain tube will remove liquid, remove humidity. Okay, remove humidity. So how humidity happen? Macam mana kelembapan ni berlaku? So dekat sini, what happened? This is cool surface. Dekat evaporator inside, we have a cold refrigerant and cool coil. So what happened? Hot air with humidity flow into cool coil, so it will make the surface have some uh, condensation. It will become condensation happen. So then water will be apa wujud lah, terdapatnya air lah dekat coil ni sejuk, dan dia akan jatuh dekat collector. So air ni akan dikeluarkan dekat sini. So when hot air flow flow to cool surface, so at the surface will become condensation. Condensation ni means apa? Condensation ni adalah water removal water in the air. Kandungan air dalam udara tu akan dikeluarkan sebab kondensasi lah. Okay, condensation. Okay, related. Okay, kenapa saya nak cerita ni? Okay, sebab if RH relative humidity is, if RH is high, so if too much humidity in your air, so the system is need to remove the water first. Okay, temperature. Normally, temperature can be reduced after RH after humidity have achieved the standard state. Okay, normally kalau dia ada dia punya chart dia. Okay, for example, chart dia contoh macam ni lah, dia ada chart dia. Okay, example so this is set point temperature with RH lah. Okay, so this is kalau chart tu ini adalah temperature, yang ni adalah humidity lah. Okay. So untuk turunkan, to reduce to set point temperature, what happen is they need to remove the humidity first, and then barulah temperature tu boleh turun. So kalau humidity tinggi, perlukan masa lama untuk to dry the air first and then cool the air. That's why, as I mentioned before, humidity also will affect the energy consumption of the indoor condition. Okay, we take 5 first, and then we continue with centralized air conditioning system. Okay, takut banyak sangat masuk Okay, kita sambung dalam 11.58 untuk centralized air conditioning. Okay, kita sambung. We continue. Centralized aircon. Okay. Why? Okay, the question is why centralized air conditioning exists. Okay. Firstly, you imagine if big building. Okay, before this lah, here. If you have big building, many, okay, many level, many room, such as government office or working office. So imagine if all the room has its own split unit. Okay. If a big building using split unit, is it possible? The question first is it possible? Is it good? Maksudnya adakah apa kekurangan dia? Boleh you agak tak? Adakah dia lebih efficient? Okay, you boleh jawab juga. Cuma saya nak tahu apa dia?
Efficient because using so much energy and the bill electric will increase.
Sorry tak apa clear lah. Boleh boleh guna. Okay, ada lagi tak? So ni banyak split unit. Okay. Okay, firstly, to cool by split unit is actually more efficient. Lagi cepat sejuk sebenarnya. Lagi okay, tak ada masalah sebenarnya guna split unit untuk to use split unit for cooling, just in case for cooling. For cooling it is okay actually. But not okay is cost. Okay, not okay is cost because all room need their individual evaporator and condenser, and then the refrigerant for split unit is expensive. Okay, refrigerant itself used in the split unit is very expensive. So that's why for big building they use a different similar cooling cycle, but a different element. For example, they use a chiller working with cooling tower, and then have a air handling unit, and also air handling unit have here, and then have a fan oil unit, FCU. Okay, I will explain later. Okay, the issue is we want to cut costs for the condenser and for the split unit, and also for refrigerant. Okay, and then if you want to service, you have to service individually. So makin take time for maintenance lah. If centralized, you just service all the main equipment, and then it's off. Okay, cost, refrigerant cost, and service. So the easy solution to cool the building, of course, use split unit, but it will effect to cost, refrigerant, and service cost. Okay, that's why main building has big building need to use big. Okay, so they use ducting. Normally, if example have many room. Okay, this example big building, many layers, many level. Okay, so they have one air handling unit. So they have one service room. AHU room, for example, and have ducting system. So ducting, DUCTI. So the ducting will supply to all rooms. Tak cantik lah saya tulis. So the centralized, the idea is we have at the one level have many rooms. Okay. The idea if one level have many rooms, so there is one, we call it air handling unit. So air handling unit has inside air handling unit has many. It has a filter. It has a coil. Okay, it has a fan, blower, many things. And then by air handling unit, this system is much slightly better than split unit, but because just one, because if this one they can air, mix air, for example, new fresh fresh plus return. Okay, so the big building, uh, by using air handling unit, they can mix. Firstly, the advantage is they can mix fresh and return air. Okay, and then in this system, yes, it called mechanical ventilation and cooling because it can mix fresh and return air. And then it will send. It has ducting system. This is a simplified, basically, basic information, basic. So normally like this. So it has a ducting system. So ducting system will supply air. So they are, it can supply and return. Okay. So much more cheaper. So one level need one AHU and supply to all rooms. Something like that. Okay. There is another system where okay, like this. So no, this is typical, which is still okay. Compared to split unit, because refrigerant is expensive, they change it to using water. Okay? Water much more cheaper than refrigerant, special refrigerant. So what they still have coil, cooling cooling coil, still have cooling coil or cooling pipe that uh, supply cooling water in the cooling coil, send to air handling unit, and then blow the cool air and then absorb the heat. Okay? So the slightly hot water or the use after keluar apa, exit the air handling, so the water becomes slightly warm, and then the system, the chiller will make sure the water become chill again. Similar. So chill water inside the coil, and the blower inside the air handling unit will blow the cool air on top of the chill water, and we get cool air. Okay. Okay, so they have air handling unit for each level. So basically, centralized air conditioning system have many types. Have many types. So this is basic one. Okay, and then it has air handling unit. Normally we call it as AHU. If you go to big building, you can find one service room called as AHU room, something like that. And then so the refrigerant is water. So what the important thing is to cool the water. So to cool the water, we need a chiller. So chiller has condenser and evaporator. Okay, so it's side by side. This one unit has condenser and evaporator. So the evaporator will always provide cool, chill water to the AHU. So this is a task of evaporator. Okay. Meanwhile, condenser is to remove the heat from the water. So the heat removal is taken care by condenser. So the hot water, to the heat will send to the cooling tower. Okay, and then the cooling tower at the top of the building will remove heat from water. Okay, and then the slightly cooler water will send back to the chiller to be chilled again. So similar cycle, but different equipment. Okay, but in the end, we want cooler we want cool water inside the coil. I think I have one more chiller. So the important things in centralized air conditioning system is chiller. The peranan, the importance of chiller to cool the water in the coil. Okay, so chiller can be divided by two types, which is water cool. Okay, if you see, okay, I just in case you can see later, I share in the WhatsApp. Okay, a chiller has two types, water cold. This look like this. So it has two. Nampak looks like a two cylinder. So one cylinder is evaporator. One cylinder is condenser. So one cylinder will supply cool always to one side. Okay. For example, this way is cooler to cool, and this way is to cooling tower. If we reflect back this figure, if we reflect this one, so one cylinder to supply chill water, one cylinder to supply the hot warm water to the cooling tower. One. Okay. So one type is another type is air cool. Okay, air cool is located to. Okay, I will explain later lah based on the video. Okay, let's fast forward. Okay, this is water cooled chiller. Similarly, what I explained before in this figure. So, okay, hopefully you can see my cursor. Okay, so at the bottom, okay, normally chiller is located at the bottom of the building. Okay, so as you can see here has two cylinder. One is for compressor. One is the black one is for condenser and evaporator. So the blue line is cool water, is the task of evaporator. Okay, so and then all the cool water will send the pipe, a cool pipe to the fan AHU or fan FCU, fan cooling unit. Okay, so from here, okay, let's see. So the chill water sent to the AHU or FCU or RTU. They are here to distribute. Okay, at this type, at this part, to distribute the air, there are many systems to make sure it's more efficient. Okay, so just in case we simplify, so the cool water sent to the distribution system. Distribution system including all the ducting and so on to all the room. Okay. So after sent to the distribution system, so the cold water will become will carry some heat, will carry some heat back to the evaporator. Okay. So in the same time, the evaporator will transfer the heat to condenser. So the condenser will send the hot water to the water cool at the cooling tower, and then the cooling tower will supply slightly better temperature again, and then send to the chiller. Okay, something like this. So this is how it works, the cycle. Okay, so as you can see here, inside here has a FCU. Okay, means if you see clearly, there are the cooling water will cool the probably here as a coil. So the coil will go to the FCU, fan cooling unit. Okay, fan cooling unit means here has a blower. It will blow to the coil and supply cool air to all the room. Okay. So the next system is okay. So this is a cooling tower on top of the building. Okay, cooling tower. Okay. You can see detail later. Okay. Meanwhile, the second example is air cool chiller. Okay. You can see different. Previously is water cool chiller is located at the bottom. So there are two phase from the distribution unit go to the chiller, and the chiller go to the cooling tower. But the air cool chiller is the water directly being cooled at the air cool unit. So no chiller. So it is a chiller, but directly go to the cooling tower. Okay, so there is difference between water cool and air cool chiller. So no underground unit. So but in this the concept is principle is to make sure the cool water can be supplied to supply cool air and to absorb heat from the room. So you can check later this video is very good for you to explain. So they are mentioned before, they are AHU, RTU, FCU. Okay, so they are many. Okay, I have to go a little bit faster. You can check the video later. So we try to cover a simple calculation for the to decide the aircon. Okay, how to before that, do you have any question regarding to centralized air conditioning system? So tadi kawan kita tanya apa beza centralized. Dia konsep dia sama, cuma peralatan dia lain untuk menyejukkan coil tu. So yang penting in term of air conditioning system, yang penting adalah refrigerant tu sendiri. So kalau split unit using refrigerant, special refrigerant, liquid to gas. Kalau centralized ni sebabkan refrigerant mahal, dia guna refrigerant as water, guna air. Okay. Itu je. So untuk nak menyejukkan air dalam piping ataupun dalam apa ni coil tu, different equipment using such as chiller, cooling tower, dan juga air cool chiller dan sebagainya lah. Okey, jelas tak setakat ni? Okay, alright. Okay, ini adalah untuk estimate. Next adalah untuk estimation cooling load yang diperlukan. Berapa cooling yang diperlukan untuk sesebuah bilik lah. So kita ambil satu, kita contoh ambil bilik lah. Untuk design besar, bangunan besar, dia lain, dia lagi complicated. Okay, ada dua cara. Satu adalah rule of thumb. Okay, another one is actual. So kita go by actual atau detail method. Okay, normally for big building or the very exact way to calculate how many cooling load or how big of the air conditioning, you should use if professional they use ASHRAE method lah. Standard by ASHRAE, American Standard for Heating, Refrigerating and ASHRAE, saya dah lupa lah. Tapi ini standards lah. So kita kena consider load, kita kena calculate heat from windows, heat transfer from doors, heat transfer from walls, ceiling, infiltration. So we can get the maybe U value. Okay, I'm not sure in this Q or U. So need to get load, calculate for if there is a building, we have to consider all of these things. Heat transfer from window, doors, wall, ceiling, infiltration. And then need to consider heat from, so ni heat from the building surface, building construction. And then need to add with the people, lightings, appliances inside the building. So, and then calculate latent load, which is humidity, and then cover duct loss ducting system, apa ni, to consider inefficiency lah. For example, duct loss, bending of the ducting mungkin akan ada mempengaruhi temperature, suhu dan supply of air lah. Okay. So normally this is the very good complete method. So you can see this link later. So we will not cover this. Just in case you want to further to get your knowledge, you need to go here. Okay, because we in your project also is only small rooms, so there is also we call it as rule of thumb. Okay, rule of thumb basically based on experience of previous people lah, okay, or previous workers. Based on experience, the easiest way, but not so accurate actually, but still can be used. Okay, so the first step, so this step is I obtained from Energy Star guide from US. So there are many. If you go to, for example, air conditioning company website, for example, Daikin, you go to Panasonic, LG air conditioning section, they have already calculator. They have a calculator, so you can use that too. That is easiest way. So just in case, if we follow Energy Star method by US, so first step is to determine the room square footage area. So for your project, you firstly identify which room you have to install aircon, and then the room you need to calculate the area. Okay, area. So next step, after calculate the area, you need refer to this table. Okay, check the recommended cooling capacity from the table. So this table. So see how many square feet of your room. So because this is from America, US, so they use square feet. So you need to, if your drawing is in meter, you need to change to square foot, and then try to find. Okay, and check. For example, 250 to 300 square feet. Basic requirement is 7,000 BTU. Okay, for example, Okay, for example, if you obtain something like this, so this is initial base BTU. Sorry, you obtain base BTU. BTU is British thermal units. But this is not enough. You need to add some more. Okay, you need to add. Consider if there is a shaded. Okay, if the room is shaded. Okay, not mid shaded means not exposed to direct sunlight. Tidak terdedah kepada matahari. Kalau bilik tu ada shaded, contohnya ada external shading. Contoh ada awnings. Contoh ni room, ni tingkap, ni wall, ni matahari. So kalau ada shading ke, ada pokok besar ke yang menghalang kena surface bilik ni, so if shaded, you can reduce 10%. Okay, so from the initial value you can minus 10%. But if very sunny, so just in case, normally dekat Malaysia ni kita boleh just jaga-jaga, kita boleh lah consider sunny lah, tak berapa shaded. So if sunny ataupun terdedah dengan kepanasan, you boleh add plus 10%. So the base BTU ni plus 10% if exposed to hot condition. And then after that, consider number of occupants will use the room. Okay, one person at 600 BTU. Okay, so now we have basic plus 10% if sunny, and then plus number of occupant multiply 600 BTU. Okay, lastly, this normally we will stop here lah. But if you provide aircon for kitchen area, so you need to plus 4,000 lah. But normally we will stop to here lah, to consider these two. So once you get your final BTU, you can find the total BTU and round up to the nearest thousand and check the BTU requirement with the specification of air conditioner from the manufacturer. So this one, okay. Kalau this BTU, you use 1 HP. If this one is 2 HP and so on. Okay. All right. So very easy lah. Okay, you just need to use this chart and follow the instruction. Okay. Okay, then for project, of course you will end after you find how many HP. But then, if you want to do market survey, if 1.5 HP aircon, there are many types. So how you will select the aircon? Which one? Which one of 1.5? What features is better? Maybe you can check the watt, the features, for example, uh, 5-star, 3-star aircon. This depend on you. Okay, you need to justify. Okay, this is example of calculation. The room size is 24 feet multiplied 15 feet. So condition is very sunny, and then 2% normally for a room. So check the size. So you can get refer to table. You can get 7,000. Very sunny at 10%. So 7,700. So at 2%, we need more of 1,200, and the total is around 9,000 BTU is equivalent to 1 HP. So you can get your size lah. Okay, by the way, I also provide you air conditioner calculator. Okay, just in case to make sure your calculation, to double confirm your calculation, you can compare manual. So manual versus calculator. Sorry, calculator. So I recommend you try to compare. If the result is equally the same, almost the same, so it's okay. But if calculator is slightly increase higher, so I recommend to use calculator lah. Okay. Just compare and just choose the bigger value. Okay. So in my practice, normally what value this is not for you lah, but normally just my experience. Whatever I receive here, normally I will plus 0.5 just for my set experience lah. But you can define based on manual or calculator. The thing is, when I have used air conditioner for some time, so I have purchased many for my house. So there is some room that I select just nice, just apa, cukup ngam-ngam, and there is some room that I just plus 0.5. So it's, I don't know, there is no scientific measurement yet, but I found that plus 0.5 is performance slightly better, but without too much energy consumption compared to slightly ngam-ngam design. It will makes the compressor work more harder. Okay, lama sikit. Okay, that is just experience. Okay, just and then you can go to, just for the calculator, I provide some from Daikin, from this one and Omni calculator, so you can compare. Right. So is there, so for after we end this lecture, I think from this week you can distribute your task. Okay, for air conditioning person, siapa yang akan kira air conditioner, dah boleh terus decide this week. Terus siapkan. Kalau boleh terus buat this week, terus siapkan. Kira-kira berapa diperlukan, terus dapatkan berapa horsepower, terus buat market survey. You nak pakai aircon mana? Apa specification, harga dia, BTU dia berapa, features dia apa, berapa star dia, you cakap lah. Boleh? Boleh tak? Right, so aha. Yang mana? Iya ni. Oh ni. Dia saya salah kira ke? 24 darab 50. Alah 360 lah. Okey ni saya salah kira ni just in case contoh. Ni 360. 360 sepatutnya dapat 9,000 lah. Sebab tu lah saya rasa macam lain macam sikit. Kenapa macam kecil sangat? So sepatutnya sini 9,000 lah. Okay, ni 9,000. So 9,000 dekat sini jadi 9,900. 9,900. Okay. Lepas tu campur 1,002. 9,900. Berapa lah? Campur 1,002 jadi 11,100, 1.5 ni sebenarnya. Okay. 11,100. Okay, 11,100. 1.5. Yes, 1.5 HP. Sebenarnya saya terfikir kat sebelum ni kenapa dapat kecil sebab saiz bilik ni agak besar juga. Saya salah value salah kira. Okay, 1.5 make sense. Okay. 1.5 make sense. 24 feet, 50 feet. Sebenarnya ni ruang bilik rumah saya ni. Saya bagi contoh ni. Sebab masa saya kira ni kenapa 1 HP tapi semasa saya kira dulu dapat 1.5. Tapi saya pasang 1.5 lah. Memang saya pasang 1.5 tapi itulah. Just in case lah ni out of topic lah. Saya memang masa saya kira ni bilik saya ni saya pakai saya install ngam-ngam 1.5. Cuma dia mencukupi tapi dia take time sikit lah sebab dia cukup just optimize. So tapi maksudnya dia kalau cuaca musim panas bulan 6, bulan 7 tu dia ambil masa lama sikit lah 30 ke 40 minit baru dia sampai set point temperature. So berbanding dengan bilik saya satu lagi atau ruang besar sikit, saya increase sebab saya dah tahu condition ni, saya plus 0.5 jadi 2 horsepower. Tapi so performance bilik tu lagi cantik lah. Dia maksudnya compressor tu kerja dia capai set point temperature lebih cepat, tapi dan dia punya compressor boleh shut down early, dan sejuk tu lama. Dia sejuk cepat tapi lama. Tapi jangan besar sangat. Contohnya patut 2 HP 1.5 tapi you ambil 2.5. Tu dah melampau sangat lah, too much lah. Tapi kalau tambah 0.5 okey lah. Ini untuk actual real application lah kalau you nak. Tapi untuk assignment ni, project ni you buat ngam-ngam lah. Sebab saya decide tu saya belum buat testing lagi, saya tak ukur lagi, just experience saja. Okey, boleh Okay, boleh siap-siap lepas ni terus bagi tugas kepada ahli. Tengok balik soalan berapa minimum saya letak mungkin 2 ke 3 tempat yang kena letak aircon. So decide terus bilik mana, terus kira, terus buat market survey. So settle terus settle buat aircon. Yang fan tu pun sama, patutnya you dah dapat plan, you dah boleh terus kira bilik saiz berapa, exhaust fan So exhaust fan saiz berapa, dah boleh settle lah, sepatutnya boleh settle. Okay, so right, ada soalan lagi tak?
Katanya, dengar suara?
Dengar.
Okay, untuk air ventilation dengan aircon, dia kena state brand apa kita pakai ke, dengan jenis apa aircon yang pakai. Macam kan sekarang ada yang green aircon. So macam mana tu kalau macam ventilation pun maybe ada banyak jenis teknologi.
Okay, sorry, ulang balik. Saya tak apa-apa dengar lah.
Okay, macam ni, dengar?
Kejap, bukan. Okay, kejap, satu. Okay, ada 2 soalan kat sini. Ada 2 soalan. Satu student tanya constraint. Okay, tak ada constraint. Saya bagi kebebasan. Tak ada constraint budget. Tapi you can make logical lah. Okay. Okay macam ni, contoh aircon. Aircon ada je yang paling mahal, mestilah dia paling bagus. Tapi dia mahal sangat sampai you rasa macam tak make sense lah, mahal sangat. Tapi ada yang pertengahan yang bagus. So you sebenarnya tu depend on you lah. So sekarang ni no constraint, harga tu tak ada constraint. Cuma saya nak you pilih secara apa orang cakap, justify lah. Dia tak rendah sangat, tak tinggi sangat, tapi features dia okay. Boleh tak? Contoh macam you betul-betul nak pergi beli, nak pasang kat rumah you. You akan beli yang paling mahal ke? Walaupun you ada duit, you mesti pun agak macam macam mana cakap okay macam ni lah, senang cerita, tak ada constraint, you decide sendiri, tapi you justify kenapa you pilih tu. Okay, senang, itu je. You boleh beli brand apa, you boleh pakai features macam mana, cuma you highlight lah features tu apa yang bagus dan kenapa you recommend pakai yang tu. Itu saja. So pasal harga tak payah kira, tak payah ambil kira. Boleh tak? Siapa yang bertanya tadi?
Boleh.
Okay, Faiz lah. Okay, Faiz. Okay, yang kedua, soalan kedua saya tak boleh dengar tadi sebab dia overlap. Siapa tadi bertanya?
Doktor nak menjawab tak apa.
Pasal harga juga. Oh, okay, tak ada pasal harga. Cuma pilih justify lah, yang penting justify je kenapa awak pilih ni. At least compare lah sikit lah, compare spec lah. Kalau murah sikit dia apa yang kekurangan dia, macam tu lah. Biasanya kalau you dah masuk ke survey aircon ni, dia in the end dia jadi sama. Contoh aircon tu sama. Contoh 3 horsepower yang paling up, contoh harga dia, contoh 1.5 yang paling tinggi sekali 2,500. Tapi ada 1.5 3,000, spek semua sama. Tapi dia 3,000 mungkin sebab dia ada ada wifi. Dia boleh benda sama tapi dia ada wifi. Tapi kalau you rasa you tak perlu wifi tu, you tak payah pilih yang paling top, yang mencukupi saja. Contohlah macam tu. Tapi terpulang lah, yang penting calculation betul. Selection tu make sense lah. Boleh. Team tu, itulah saya sebab korang pun bukannya tak tahulah korang mengenali satu sama lain kan. Kejap Saya rasa untuk assignment ni, saya rasa saya akan upload malam ni, so besok dah boleh buat lah. Sekejap saya rasa macam ni, saya explain. Okay, macam ni, saya rasa saya akan buat group dulu. Saya akan buat group dulu sini. So kat sini saya akan buat group for assessment pula. Dekat group activities lah. Saya akan buat group dulu. Assignment. Saya buat terus lah. Assignment group. Tapi yang ni based on section lah. Saya rasa sebab auto ni based on section. Kejap. Assignment group save. Assignment group. Nanti bila masuk sini, kita boleh buat group wizard. Dia by section lah. Boleh tak? So dekat sini saya akan kira total section 1 berapa orang. So dia akan jadi group lah. Okay, saya buat terus lah. Contoh student list ada 55. Ni masalah ni. 55. Takkanlah satu grup ada 3 orang. Saya akan macam mana dia akan jadi memang satu grup tu akan 3 orang lah you pandai-pandai lah. 55 bagi 2. 55 bagi 2 maknanya 27 kumpulan. Okay, sini group wizard, total group 27, banyak tanda ni. Group. Okay, max group. Total group, max student, each group 2. Add. Ni group lah, group lah. Okay, group. Okay, ni group untuk assignment. Cuma group last ni 3 lah. Macam dah siapa cepat dia dapat. Boleh ke? Okay. Tapi 3 ni adalah siapa yang dapat 3 ni dia punya, kalau dekat dalam soalan tu dia cakap minimum 2 strategis. Yang 3 orang ni kena 3 strategis so group yang 3 orang kena minimum 3 strategis. Nanti upload lah soalan dia. Okay, first kali you pergi sini, you decide siapa group, berkenalan dulu siapa lah you punya group kat sini. Mungkin secara rawak, mungkin ada pair. Yang tak ada pair tu you join je mana kosong. Okay, you kenal dulu you punya group, lepas tu you pergi dekat individual assignment. Nanti saya akan update kat situ. Saya akan update kat situ lah. So dia akan hantar sebagai individual. Tapi tak apalah, yang dua-dua orang tu dia hantar report yang sama lah. Okay. So individual, dia sebagai individual, tapi 2 orang tu atau 3 orang tu dia akan hantar report yang sama. Cuma kalau 2 orang, seorang buat, seorang tak buat, maksudnya yang seorang je lah hantar. Yang lagi seorang dia tak hantar lah kot. Okay. Itu. Okay, jelas tak?
Jelas.
Setuju tak cara ni? Okay, setuju
saya setuju.
Dia sebab dia tak ada group assignment, dia, ni group activities boleh juga kot buat kat sini terus. Video group activities, yelah group assignment lah. Buat, mungkin hantar kat sini terus kot. Senang sikit. Tapi tak apa, yang penting kita dah ada group dulu. Nanti yang lain kita discuss lagi lah. Okay, macam tu lah. So saya rasa tak sempat nak cover chapter 4. So chapter 4 minggu depan saya try cover sekaligus lah. Simplify sikit sebab chapter 4 tak ada calculation. Chapter 4 adalah fire safety and building transportation, totally theory. So saya akan cover separuh dan separuh lagi mungkin you akan minta belajar sendirilah, baca nota. So minggu depan minggu ke-11. Okay, minggu ke-11. Kemudian kita try ada lagi 3 minggu untuk cover elektrik. Elektrik saya rasa 2 minggu. Dan final week adalah water supply, 1 minggu. Dan kalau ada makluman tambahan, saya akan buat video untuk ulang kaji. Kemudian projek saya bagilah sampai, you boleh siapkan sampai week 14. Cuma lepas tu you try buat report, buat video, submit by study week. Cuma assignment tu 2 minggu lah. 2 minggu dari tarikh hantar. So tak susah pun assignment tu. Buat pun 2 orang, 3 orang. Sepatutnya cepat lah. Okay, itu saja daripada saya. Thank you very much. Okay. Apa? Oh, season 2 buat terus Okay, saya buat terus. Session 2, student lead.
Doktor, next week online ke macam mana?
Apa?
Next week online ke apa?
Next week kita face to face lah pula. Saya rasa kan saya rasa buat try lah face to face. Okay, minggu depan kita face to face lah, cepat sikit. Okay, session 2 56. Okay, ingat lah 56 bagi 2 28 bulan. 28 bulan. Sign. Save. Okay, and then assignment, group wizard. 28 group. Okay, maksudnya kena on kan. Ini nak allow you tukar group ke tak? Keluar masuk. Ikutlah. You nak keluar masuk. Okay. Yang ini on. Okay. So dah boleh select group lah. Okay, kejap kita ambil masa untuk attendance. Okay, kejap take note untuk calculation ni tadi saya salah, terima kasih pada yang tegur. Okay, dah padam. Okay, kita tunggu sebentar untuk attendance. Mana? Macam mana nak buka ni? TCIS. Okey, boleh selesaikan attendance. Siapa yang tak boleh scan boleh tulis dekat chat box. Terima kasih. Kita jumpa minggu depan. Face to face.